Here we have question on transformation of exponential function. Question 38. Given graph of function f of x equals to 2 to the power of x, draw g of x equals to 2 to the power of minus half x plus 1 plus 1. Explain transformation in correct sequence. We are already given the graph of f of x equals to 2 to the power of x, and we can use this graph to draw the transformed function. Okay. Now, as you see, the transformed function is not factored. So before even writing the transformation and sketching graph, we should factor and write it in correct order. So let me write this as g of x equals to 2 to the power of, I'll take minus half common, minus half, then within bracket I put x, and since I take minus half, I have to multiply this by minus 2. So I get minus 2 plus 1, correct? So that becomes my transformed function. You can check your answer by expanding it. So when I open the bracket, I'll get minus half x, and minus becomes plus, and 2 divided by 2 is 1. So we get plus 1, correct? Now, that is your function. So there is no vertical stretch or compression or reflection, but here we have minus, and that is your horizontal reflection on y-axis, correct? And then you have to, and what does this half mean? Half is your horizontal stretch by a factor of 2. And then we have horizontal translation, 2 units to right and 1 unit up, vertical translation, correct? So let's try to do these transformations one by one on the graph itself. So the critical points which we should be considering are, one is at x equals to 0, that means anything to the power of 0 is 1. And then anything to the power of 1 is the base itself. And then minus half will give me 1 over 2. So these are good points to start with. So when we want to do the reflection, then these points get reflected, and this comes here. This is invariant. It is remaining on the y-axis, and that comes here, correct? So that is how these points will get transformed. This point will go here. So I have a function which will be kind of going like this on this side. Right? That's a reflection. And here at 2 we have 4, but here this 4 will come for minus 2, correct? Similarly, we have at 3 8. So that 8 will be the value at minus 3. With that, I can reflect this graph on y-axis and sketch it. Is that okay? And similarly, this approaches 0 as it approaches infinity. So we have taken care of the minus sign. Now, how will you do half, the k value? It means vertically stretched by a factor of 2. That means multiply everything by 2. So here, if I multiply, this is the y, this is the x value of 0. If I multiply this by 2, it remains 0, correct? We are multiplying only x values, remember that. And this is at 1. So 1 multiplied by 2 will push it on this side. So that is a horizontal stretch. Do you see that? And 2 will push it on this side, correct? This 3 will give me 3 more. So this will come at minus 6. So you see the graph actually gets stretched horizontally by a factor of 2. Now this remains here itself, and 1 goes to 2, and this goes to 4, correct? Like that, it gets stretched. So I can draw my stretched function now, which is kind of like this. I know this part is not all that good, but still it's not bad. Now we will do the third transformation, and that is we'll move each unit 2 units to right and 1 unit down. So we'll do both simultaneously, correct? So 2 units right and 1 unit down. This comes here. 2 units right, 1 unit down. This comes here. And 2 units right, 1 unit down. It comes here, right? Remember one thing. Oh, sorry, 1 unit up. I'm doing wrong. So we have to do 2 units right and 1 unit up. This is plus 1. Wait. So 2 units right, 1 unit up. Good time to catch it, right? 2 units right, 1 unit up. Let me use a different ink also. This may create confusion otherwise, okay? Let me draw it in. Okay. Let's take this color. It's similar, but okay. 2 units right, 1 unit up. So we get this color. 2 right, 1 up. Here we are. 2 right, 1 up. Here we are. 2 right and 1 up. Correct. So what basically happens is your horizontal asymptote moves by 1 unit, right? So it's better to draw a dotted line here so that we know. So that is going to be our horizontal asymptote, right? Because these figures are very close to this. So 2 right and 1 up, kind of like here, right? So 2 right, so all these points will be very, very close to this, correct? So we have a function here which is the final g of x is kind of going like this, and this becomes a horizontal asymptote. And here we have correct. So that is g of x, right? This is g of x, which is equals to 2 to the power of minus half x minus 2 plus 1, correct? Now, it's a good time to write down all our transformations here. So let's write down transformations one by one, starting from left to right. So we can say first, this minus indicates the reflection on which axis? Y-axis. Correct? Second, horizontally stretch by a factor of 2. 1 over half, that is by a factor of 2. And then how about the translations? I'll say translate 2 units right and 1 unit up. Is it okay? So these are our transformations. I hope you understand how we did all this. And it's important to take care of few critical points, and they were at x equals to minus 1, x equals to 0, x equals to 1, and horizontal asymptote. We also took this point x equals to 2. Okay, so that gives us pretty accurate graph of g of x. I hope you understand. Go through it and try to understand transformations of exponential functions. Thank you.